Hi my guys, welcome to Khalil Tronics. In today's video we are going to introduce an electrical modeling under the course of signal and systems. So as the passage given, the basic passive elements of an electrical systems are resistors, capacitor and inductor. Table 1 summarizes the relationship between a voltage across and the current through the element. Table 1, the relationship between a voltage, current and electrical passive elements is given. The resistor is given as V of T is equal to R, then I of T, where I, if you make I subject, we have I of T to be equal to B of T then over R. Then for the capacitor, we are having a V of T is equal to 1 over C integral of I of T dt. Then by making I to be subjects, we will have, so by taking differential both sides, we can have dV is equal to 1 over C then d, then integral of I dt, I of T dt. Here is go differential times integral, and from where we have C dV is equal to I dt, I of T dt. Then from here we can say I of T is equal to C dV over dt. So this is the for the inductor, we can say the voltage across inductor element is L di over dt, or I can say L di dt. So by making I to be subjects, if we integrate both sides, we will have 1 over C integral of B of T, sorry, here is B of T, V of T, then dt. Okay, so this is the three basics element as we see in the given table. So here I is I of T for the capacitor element is C dB dt. For the inductor is 1 over L integral of V of T dt. For resistor is V over T. Okay, so we are going to take a circuit to demonstrate the effects. So by taking a circuit, let's take a resistor. We have we take a resistor. Okay, so here is our resistor, here is the current flowing, that's I of T, here is B2 of T, here is B1 of T. So from here, by applying a KVL, that is Kirchhoff voltage law, we can have a V1. Here the polarity of resistor is always positive to negative, so we can say B1 of T minus the resistor, that is resistor across the voltage across resistor, we have I times R, then minus the V2 of T must be equal to 0. So from here we can say V1 of T minus V2 of T is equal to IR. So normally we can say V1 from the circuit, we can say this voltage minus this voltage is equal to the voltage element in the circuit. Here we can say B1 of t minus B2 of t is equal to IR, that's I of t. So for capacitor, we are having a V1, then we have capacitor at here, and here you have a V2 of t, here B1 of t. Applying the same procedure here for capacitor, applying same procedure, we can say V1 of t minus B2 of t must be equal to the current, the voltage across capacitor element. Remember, the voltage across capacitor element is equal to the voltage across capacitor element is equal to 1 over C integral of I dt. Okay, so from here we can say V1 minus V2 is equal to 1 over C integral of I dt.